Good morning, dear students. Right, welcome to this session. I thought of explaining how to formulate this problem for you, and I'll leave it to you for solving, because this problem consists of typical practical data that you must convert to a problem on paper to the form where you are able to solve. So that conversion process I'll just explain you. That's how this session is being kept for you. Okay, right. So let us see. A suspension bridge of span 80 meters and width 6 meters. Okay, which means let me take empty page. So where right? So this something I'll draw the plan of that one. Means when you see it from top, how the bridge looks like. Okay. Okay. Right. Let me take this as 80 meters. This 80 meters is 6 meters width of road, width of the carriageway. Okay. So this is where the vehicular movements is now allowed. Okay. So this is the given data that if you see span 80 and width 6 meters. He is having two cables stiffened with 2 hinged girders. There are two cables. Okay. So let me draw a 3D view for this. Okay. So imagine that just a 3D view for this. Okay. So just take the path like this. Okay. So this is no, the pathway or the carriageway that is being taken. Right. So above this, there should be a cable, right, to hold this, no, girder. Okay. So this is something like this, and there should be another cable. So this is of to hold this one to hold this. So you need to have one cable, one end. Okay. To hold one end, you need to have one cable for this. Okay. And to hold the other end also, you need to have uh, another cable. Okay, where you are going to hold the other end also like this. Okay, so this is how like this. So this is there are two cables, two main cables, and here is the vehicular path that we allow. Okay, so this is what is a problem. So here is a girder, one girder. Here is another girder. Okay, two girders. Okay, so you don't need to take up this. This is like three-dimensional. The data given to you is for three-dimensional. Okay, so you have to convert this to two-dimensional. Means you just need to take only one girder and one cable. That's all. Okay, the other one is to be designed in the same way. Okay, so this is how you should convert that problem a three-dimensional problem, you have to convert like this. Okay, how you convert it? So what are all the given data you see? So dead load is given as uh, uh, 5 kilonewton per meter square. You observe here. It was just earlier per meter UDL. Now this is pressure. 5 kilonewton per meter square is the pressure. Okay. So what you will do? 5 kilonewton per meter square pressure is given on this one. Okay. 5 kilonewton per meter square pressure is given. So multiplied by area, on which area it is acting? 80 into 6. Okay. So into 80 into 6 will give you total load. Okay. How much is this? 6 5 is 30. 30 and 300 into 8. 2400 kilonewtons. Okay. And now what do you want? This is total point load. We have converted that into total point load, like area into the pressure will give you total point load. So you need UDL, right? You need UDL along the girder. This is the girder. Okay. This is where the girder is there. Okay. This is one girder. This is another girder. So you need load to be shared to one girder, means half of the load will be shared to one girder and another half of the load will be shared to one girder. So this is total load. So make it into half. Okay. So how much it is? 1200 kilonewton. Okay. This is for two girders and this is for one girder, kilonewton. And now to convert this to UDL 1200 divided by length of the girder is 80. So 1200 divided by 80. Okay. So 120 divided by 8. Let me tell you the value. 120 divided by 8. 15 kilonewton per meter. Okay. 15 kilonewton per meter is the UDL onto this girder. This is from dead load, right? Right, for full span. Okay, so this is full span dead load. Now what? Live load is also given. What is the value? 10 kilonewton per meter square, which covers the left half of the span. Okay, so which means left half of the span means this is the area over which live load is acting. This is the area. So now to calculate live load value, so 10 is the value, kilonewton per meter square. Okay, just 10 kilonewton per meter square, which covers left half of the span. Okay, right. So what is the area, total area? 80, half of 80. So it is 40 into 6. This is total load, right? Kilonewton per meter square into meter square. So 24. Again, 2400 is the total load. Again, this should be shared to half of the load to one girder, another half to another girder. So by 2 will give you 1200 kilonewton. This is live load. Okay. And you need UDL only for where the load is acting, only for left half of the span. How much length? 40 meters. So 1200 divided by 40 is the length. Okay, so that will give you 30 kilonewton per meter. 30 kilonewton per meter is the UDL over left half of the girder. So now if you just see the loads on the girder, okay, so now let me draw the girder. So now your problem is simple. So this is the span 80 meters, and now the cable. Okay, let me draw the cable. Okay, so just put it down at the center. Let me draw it again. There has to be some way to just lock it down. Okay, that's how it is. Right. So this is how the cable. Uh, now the suspenders. So you just need to fill up the suspenders. So just this is the span. Okay. Right. So this is 80 is the span. Now your problem is to be formulated, and central dip 8 meters. I think so. Let's go back to the problem. So central dip is 8 meters. Okay. Right. So now this is the girder where the hinge support. So you have to do all these stuff before you go to solve the problem. Okay. Right. So dead load acting on the girder. Now there are no point loads, only UDLs are acting on the girder. So this is the dead load acting on the girder. The value 15 kilonewton per meter is calculated on one girder. Okay. Right. Now this is the center. So say just drop it down the center. So live bigger one is acting just 30 kilonewton per meter. So instead of point loads, now we have UDLs. That's all. No other change. This is A dash. The remaining problem is as usual. B dash, A, B. Okay. So as this is not two hinged stiffening girder, so you have to calculate equivalent UDL first to start solution, right? So what is total W divided by total span? That's it. Okay. So what is total load here? 15 into 80. Okay. Right. Again it is 15 into 80, 1200, and 30 into 40, 1200. So total load 2400. Total load divided by total span 80. So what is equivalent UDL? 30 kilonewton per meter. Okay, right? So 30 kilonewton per meter is the equivalent UDL that is acting on the cable as well as on the girder. Okay, so from here the remaining procedure is as usual. Okay, so this is the required workout because the given data is of three-dimensional in nature, so that you should convert into two-dimensional and formulate your problem in the right manner. Okay, so for this purpose I have just extended the session to one more session. uh, Rather I have completed unit 3 in the last session itself, but I thought of explaining you this formulation of the problem for this example given. So whenever such width of the carriageway is given, okay, where you find this, whenever you find this, width of the carriageway is given means, so you will be using two cables, one end one cable, another end another cable. So it is that the full bridge is given to you. You have to little formulate all these pressures and all shall be converted to UDLs as I explained. Okay, carefully follow and try produce all these diagrams that I have drawn you uh, in the separate sheet. So try draw yourself all these diagrams and try calculate on your own all these values. Okay, just practice a little much over this. Okay, if at all such problem is given, you need a little more practice for this, right? If at all straight away a point load UDL on the girder is given, there is no problem like this. Okay, you have stiffening girder, like span something, dip something, and there are loads something. If it is like this, there is no problem. But if the problem is given in terms of a three-dimensional full bridge data, then you are going to face the problem, right? Okay. So that's all with this unit 3 cables and suspension bridges topic. Okay. So with this we are closing unit 3, right? Thank you so much.